Hello, Thameem. How are you? I'm audible to you. Yes, Thameem. Is I'm audible to you?
Yes, sir, you're audible, sir.
Okay. So let's start studying. In the previous class, we were studying the Henry's law. We have given you some questions over it. Have you practiced that one?
Not yet, sir.
I
I haven't got time yet, sir. That.
okay. So today we shall be studying in the previous classes we were studying the Henry's law. And in the Henry's law, what we specially studied, we studied that the dissolutions of gas in liquid depends on the mole fractions of the, means the pressure exerted by the gas, means the amount of, we can say the solubility of the gas in the liquid is directly proportional to the mole fraction of the gas. Okay. The pressure applied over the gas that we have studied in the previous class about the Henry's law. Okay.
Yes, sir.
So what was Henry's? What was Henry's law? Read the Henry's law. Have you noted that one?
Yes, sir, I'm taking it. 1 minute, sir.
Read it, please.
Is Henry's law is states that amount of dissolved gas in liquid is directly proportional to partial pressure.
Is that means the amount of gas that is dissolving over the liquid is directly proportional to the partial pressure of the gas. Okay. So
Yes,
here
sir.
we are just having this partial pressure and we are just going to explain you now. Today we're just going to study the Rawls law. Okay. What does Rawls law
Okay.
state? Let me explain you here from the
Yes,
with
sir.
the help of NCRT. Okay. Now let's study. So this is Rawls law is about the dissolution of two volatile liquids for a solution of two volatile liquids. For example, if I'm saying there's no gas, we are not talking about the gas. Okay, we are just talking about the liquids. Okay, so what does Rawls law state about? For example, consider a binary solution for two volatile liquids. So Rawls law is applicable for two volatile. What are volatile liquids? Can you tell me? Volatile means that has a very low boiling temperature. Okay, simply means the liquid that can evaporate easily are known as volatile liquids. Okay, and we
Okay.
divides that in the component 2 and 1 and 2 taken in a closed vessel, and we have just closed them in a vessel. Okay, and both the components evaporate eventually in an equilibrium. Both are evaporating. Okay, now you know that when there is a two volatile liquid, so one volatile liquid will be means both the particles will have some means surface particles over it. Like for example, this is A and this is B. They will form. Okay, so they will be like this. Means the both A and B are going to have their surface particles. Okay, so in 1886, okay, Raoult gives a law known as Raoult's law, and what he said that for volatile liquids means if we are dissolving the two volatile liquid, the dissolution means how much they can dissolve easily, and we can say the partial vapor pressure of each component of the solution. First, let me explain you that what is partial pressure. What do you mean by the word partial pressure? For example, where we are just talking about the in the vapor phase, because in the liquid phase, they are not, the liquid does not exert pressure. Okay. So for example, if I'm having this component, okay, and this is, if it is capped in open air, so there is an atmospheric pressure over it. Okay, it is not evaporating. Okay, it is not evaporating because the atmosphere is exerting a pressure over it. Just you assume that it is, this solution is capped in the open air. Okay.
Yes, sir.
Okay, and when it is kept in
Yeah.
open air and we have closed a lid over it, and we just remove it, and we just removed this one. Okay, we just removed the lid over it. So the pressure that during that time, the pressure that it is exerting during the time, okay, the pressure that it will exert over it will be considered as the partial pressure of this gas, of this liquid in the vapor phase. Okay, so this partial pressure is exerted by the gas, so we'll simply say that the vapor phase, in the vapor phase it is going to exert pressure. Okay, so the partial pressure vapor phase of each component of the solution is directly proportional to the mole fraction of the solution. First note it down, the mole fraction, then I'm going to explain you. Write down the Raoult's law. First definition: the solutions of volatile liquids, the partial pressure of
So
each,
are you
what do you
because
say?
I don't think
What do you are not able to see the screen?
no, sir.
Oh my God, I have been teaching you. What was that? Why didn't you say that I'm not able to see? Sir, are you teaching something? I've just explained you
I think
this one. I have just explained you this one. What is that? Even you can't say it. Sir, I'm not able to see something. Are you writing something?
I thought you would like maybe start from now. I don't know. I thought you would start it late.
Okay. So let's you write here. That's what is Raoult's law. Raoult's law is applicable for the solutions of volatile liquids. So note it down, for the solutions of volatile liquids. Volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to the mole fraction of the solution. That I'm going to explain you. First, note down this black bold letter definition.
Yes, sir.
Happening.
Yes, sir. Copied.
Is recording. Okay. Okay. So I'm
Yes,
saying
sir.
here is that when you are having a mixtures of uh, two volatile liquids, okay, and for example, you are having a mixture of two volatile liquids, and this is having a particles A, and this is having a B particle, then A particle, then B particle, then A particle, and then B particle, and then A particle. Okay, they both are having. So you know that the surface will have, because they are mixed together, so surface will have both the particles at the top, both the surface. For
Yes.
example, if you are adding ethanol and water, suppose, and you are mixing them together, so the particle of ethanol will be there, and the particle of water should be there. Okay, at the
Yes,
surface,
sir.
both the particle will be present. So I'm just representing A, B, A, B, A, B, mean particles of solute and solvent. Okay, so when they are just, when you are vaporizing this, okay, so we'll say that the pressure exerted by the gas, the which gas is going to exert more pressure, depends on the partial pressure. Means the partial pressure exerted by the gas is directly proportional to the mole fraction of the gas in the solvent. Let me explain you what is partial pressure first. Partial pressure or partial vapor pressure. For example, this gas is exerting a pressure. Okay, when you are having a mixture of this one, so this, and you start heating it. Okay, so this gas will exert a pressure over it. Okay, over the surface. Let you are just let you keep it in the closed container here like this. So it will start keeping exerting a pressure over it. And let you are having a scale here, that how much the pressure is, you are just reading here. Okay, this is the pressure gauge which can record the pressure over it. Okay, now you start hitting it. Okay, so what it's saying here is that in the vapor phase, the partial pressure means the total pressure will be equals to Not only the single gas is going to exert the pressure, both the gases, both the liquids, because both are volatile, both can evaporate. So both can evaporate means both will be converted into vapor. Are you getting my point?
Yes, sir.
A will also evaporate and B will also evaporate. The both will evaporate. So both the particles will hit this surface and will exert the pressure. So it is saying simply that the partial pressure means the pressure exerted by A only, the particle of A only, is directly proportional to the mole fraction. The amount of mole fraction is directly proportional to the mole fraction of A. If B particle is exerting more pressure, it means the mole fraction of B is more in the soil here. Okay. For example, if I'm saying that XA is 0.2, then XB will be in this one will be 0.8. Are you getting my point?
Yes, sir.
Because the mole fraction sums to 1 mole fraction of A, and it is only talking about the for a volatile liquids. Okay, for a solution of volatile liquids, and it is talking about the two volatile liquids. Okay, for a solution of two volatile liquids, not 3, not 4, not 5. Okay, you understood?
Yes, sir.
So what it is saying, just concentrate here, that if you are having two volatile liquids, they are mixed together, and let A is the mole fraction, mole fraction of X is the mole fraction of, or 0.2 is the mole fraction of A substance, and 0.8 is the mole fraction of B. Okay.
Yes, sir.
So if I ask you that which substance in the vapor phase will exert more pressure, the partial pressure means, so which will be exerting more pressure. So you know, simple, the mole fraction of B is more, so B will exert more pressure. Okay, B will
Yes, sir.
exert more pressure. So simple words, if I'm saying here is that if you are having two gases, if you are having two uh, liquids and they are evaporating both simultaneously, then the pressure exerted by both of them on the wall of the container when they are evaporating is directly proportional to the mole fractions. Is directly proportional to the mole fraction in the liquids. Means if I'm saying that the partial pressure exerted by A, or you can take A, is directly proportional to the mole fraction of A, and the partial pressure of B will be directly proportional to the mole fraction of B. Okay, and then total pressure will be, what is total pressure? P total will be equals to the total pressure that will be exerted will be the partial pressure of A plus partial pressure of B.
Yes, sir.
Okay, so, and you are saying that it is directly proportional, and you know, since this is PA and this is mole fraction of A, and you know that this is a pressure unit. Okay, this is a pressure and this is the mole fraction. So it is saying directly proportional, and mole fraction do not have any unit. Mole fraction do not have any units. It is unitless quantity. Unitless quantity. And you are equating it with the pressure has some quantity. So there must be, it should be multiplied with something which is having the unit of pressure, so that the pressure will be equated to pressure. How it can be equated? Can you equate the kg with liter? No, you cannot equate kg with liter. The different units cannot be equated. So how can the pressure can be equated with something that is unitless quantity? So it means that we have to multiply it with something which is pressure, and we just multiplied it with P1. Okay. So here we are just exerting that it is the P1 is the partial pressure of the gas in the pure state, when it is only having only when it is when I'm saying that it is a particle only here in this one, a pure state, no other solvent is added to it. So if I'm saying here that P total, or PA will be equals to P naught into XA. Okay, what is PA? PA is the partial pressure of A. PA is the partial pressure of A, and P naught is the partial pressure in the pure state of A. It is the partial pressure in the pure state. Okay. So O naught means, P naught means, it is simply partial pressure of A in the pure state, pure state and pure state. Okay, and this is the partial pressure in the solution when when it is mixed with B. Okay, got it?
Yes, sir.
And here similarly, partial pressure of B when it is mixed with A will be equals to when it is having pure state A into XA. Okay, then P total will be equals to, laptop is again and again it is showing some curves. Okay, now I'm saying that P total, what will be the value of P total? So according to Dalton theory of pressure, the total pressure exerted, for example, if I'm having this liquid and this liquid has A and B both, A and B both, okay, and they are exerting a pressure. So this is A particle, this is B particle, then A particle, then B, then A and B. So pressure will be exerted by A also and B also, PB. So both will be exerting the pressure. The total pressure will be equals to partial pressure exerted by A plus partial pressure exerted by B. So are you getting this one?
Yes, sir.
So both are exerting the pressure. So P total will be equals to this. You can write P total will be equals to P. Now A value you can put it as P naught XA plus B value you can put P naught B into XB. Okay, got
Yes,
it?
sir.
So here please note it down. Note it down this derivation up to here. Up to here, please note it down from here. As the component P1 will have to here you have to write it.
Okay, sir.
You've done this one
Yes, sir.
up to here.
Yes, sir.
Now, if I'm going to explain you in terms of A and B, so if I write here, P total is equals to, I'm writing 1 because you have written 1. So I'm writing P naught 1 into X1. Okay, and then plus P naught 2 into X2. Okay, mole fraction of 2. Okay, what is this? This is the vapor pressure. Vapor, this is the vapor pressure. Video because it is taking much. Vapor pressure in the pure state, in the pure state. Okay. Now the P total can be written as, what is P naught? What is P naught, P1 naught and P2 naught? So you can write it P1 naught as, and what you can write as X1. What you can write as X1? You can write X1 as 1 minus X2. Can you write it like this way?
Yes, sir.
Why? Because you know that mole fraction, if I'm writing mole fraction XA, so how can I write it? I can write it 1 minus XB. Okay. If I'm going to write a mole fraction of B, so I can write it 1 minus XA. Okay, the same x1 can be written as 1 minus x2 plus P naught 2 into x2. P naught 2 into x2. Okay, now multiply this one and this one. What you will get? P1 naught minus P1 into x2 plus P naught 2 into x2. Now take the x2 as common. So you can write P1 and there you can write x2 when you take the x2 plus. So you can write x2 as common. X2 is common. So you can write P2 will be because P2 will be positive here. So I'm just writing P2 first and then P1 minus. Okay, and this will be x2. So in the terms of mole fraction of second, you can write this one, this formula.
Okay.
So first, let me explain you one more thing here again. What does Raoult's law explain you?
Oh,
You done?
no, sir.
Note it down, please.
Yes, sir.
Please do this derivation one more time by your own. Please do this derivation one more time without seeing it. If you watching this one, and try to take a small help. Okay, and where you getting stuck, let me know. I will going to explain you this one again. Please
Okay, sir.
start doing it from the starting. That it is saying that P1 is directly proportional to x1. P2 will be directly proportional to. Why it is saying? Why it is revolving again again? Is my skin is getting blackened again in front of you?
Yes, sir. It's becoming black.
It's becoming black. I check there is some background problems. I don't know why it is happening so.
Okay, sir.
Okay, just wait a minute.
Okay.
So now here you can check that P2 is directly proportional to X2. Okay, means what is saying that when then when there are two liquids they are dissolving. Liquid 1 and liquid 2. Okay, liquid 1 and liquid 2. They both are dissolving. Liquid 1 is they both are forming the mixtures. So when they form the mixtures, they will evaporate. They will evaporate,
Evaporate.
evaporate, and they will exert a pressure on the wall of the container. Since they are the two liquids present, so both the particles of both the liquids will evaporate.
Yes,
Is
sir.
that clear? If A particle will evaporate, so B will also evaporate, and the both are contributing in exerting the pressure. So the both will have some pressure. So that is called partial pressure. Partial pressure of A in vapor phase is directly proportional to the mole fraction. Is directly proportional to the mole fraction means if you calculate the mole fraction in this liquid of A, that will be direct. If A has more mole fraction, then A will exert more pressure. If B has more mole fraction in the liquid, then it will exert more pressure. So simply it says that the vapor pressure exerted by the liquids, the volatile liquids, is directly proportional to the mole fractions. Okay. Now, if I
Yes.
ask you that, for example, this have some particular container. This is container A. Okay. This is container A and it is exerting some pressure. It is closed container. Okay. Now, if I suppose remove this A from it and I just take the same amount, the same volume of A, only A, not two, not B, only A particles or one particle or one substance, another is B here or two, according to us, is one and two. Now just taking, we just apply the same condition that we were just applying the previous one, the same temperature, same thing. Okay, then in this condition, the alone A will exert some pressure because A will also evaporate. Okay, it will
Yes.
also exert. And here B will also evaporate. Only there is B particles or second particle. It will also evaporate. So at this time, when it is in pure state, its pressure will be calculated. What pressure they are exerting, then it is known as P1 naught. And at this time, the pressure that will it exert, that will known as P2 naught. And when they in this container, the same container, the same size container, okay, the same size container we are having here, and my laptop is hanging. Okay. I'm just taking the same container, and this time I have added both the gases, but the volume of them same. Okay, means if suppose it is having 3 volume, it is having also 3. It is not having 6. It is also having 3. Both have 50-50%. Okay. Now
Yes,
at
sir.
this time, this A will exert pressure and this B will exert some pressure. A will exert some pressure, B will exert some pressure. So they both are exerting. So in this condition, the pressure P1 will be directly proportional to the mole fraction. Means the amount of A is present in this one. If A particle is more, the P1 will be more. If B particle is more, B substance particle is more, then B will exert. It's simple. If in the solution A substance is more, it means its mole fraction will be more. So if A substance is more, then it will exert more pressure, na? Its particle will go and hit the wall of the container.
Yes, sir.
Are you getting? So we will say that in the Raoult's law says that the partial pressure P1 is directly proportional to the mole fraction. Partial pressure exerted in the solution form, and they are the two liquids mixed together, is directly proportional to the mole fraction. Then why we are multiplying this? Why we are saying that P1 is equals to P naught x1? Why we are just multiplying this one x1? It is saying mole fraction because you know that it has unit ATM, or it can have unit Pascal, it can have unit bar something, and mole fraction do not have any unit. So how can a unit with pressure can equate with the unit which is the quantity which do not have any unit? So we must multiply this one so that it will also become pressure. So we have to multiply. This is the rule for the physics, that the two same physical quantity can be equated. So now it do not have any unit. The mole fraction do not have any unit, and this P naught has unit. Okay. So that is ATM. It is also pressure, but it is in the pure state. It is P1 is in the mixture state. Okay. So P1 will be equals to P1 naught into x1 mole fraction. Where what is x1? X1 is the mole fraction of uh 1 in the solution. Okay, you understood? Are you getting this one, Thameem?
Yes.
You didn't get this one?
Yes, sir.
You didn't get this one. So let me explain you that it's the Dalton law of partial pressure when they are the two liquids. Let me explain you this one with the help of video.
Your audio
Just
is
my audio is lagging. Okay, just a minute. Let me explain you with the help of some. Just a minute. You can understood it with the help of. Actually, my laptop is heating.
hello, sir. Can you hear me?
Yeah, I can hear you.
Oh,
That I'm going to share it to show you. Is the screen is visible to you?
yes, sir.
I mean, where are you from? Means, can you listen the lectures in if it is explained in Hindi?
Yes, sir. Sure, sir.
Sure.
Yes,
Okay.
sir.
So let you explain it. Let I'm going to explain you this one so that you can understand it more betterly. Okay.
Okay, sir.
Because animations plays a very important role. So is the screen is visible to you?
Yes, sir.
Okay. The video is visible.
Yes, sir.
Okay. Say you
Yes,
let
sir.
understood this one.
है जो कि फिजिकल केमिस्ट्री और थर्मो रोल्स लॉ एक फंडामेंटल प्रिंसिपल है जो कि फिजिकल केमिस्ट्री और थर्मोडायनामिक्स की फील्ड में यूज होता है और सॉल्यूशंस के आइडियल बिहेवियर को डिस्क्राइब करता है। इसे एक फ्रेंच केमिस्ट फ्रेंकोइस मरी रेआउट मिला इंटरैक्शन होगा। According to Rawls' law, partial pressure of a component is equal to mole fraction of the component multiplied by pressure at pure state of solution. इसको हम ऐसे रिप्रेजेंट कर सकते हैं PA is equal to XA into P नॉट, जहां पर PA सॉल्यूशन का वेपो प्रेशर है, XA सॉल्वेंट का मोल फ्रैक्शन है, P नॉट प्योर सॉल्वेंट का वेपो प्रेशर है। रॉल्स लॉ को दो तरह से डिस्क्राइब किया जा सकता है, वेपो प्रेशर और पार्शियल प्रेशर। आइए इसे डिटेल में समझते हैं। जब हम सॉल्वेंट को खुले में रखते हैं तब सॉल्वेंट मॉलिक्यूल्स लिक्विड सरफेस से इवैपोरेट होते हैं। उसके बाद वेपो फेज और लिक्विड फेज के बीच इक्विलिब्रियम एस्टैब्लिश होता है।
इक्विलिब्रियम एस्टेब्लिश होने का मतलब क्या होगा?
लिक्विड सॉल्वेंट के
इक्विलिब्रियम एस्टेब्लिश होने का मतलब ये होगा कुछ टाइम के बाद जब हम लोग उसको क्लोज कंटेनर कर देंगे तो कुछ अमाउंट ऑफ लिक्विड्स के जो वेपर के जो पार्टिकल्स हैं वो कहाँ पर आने शुरू हो जाएंगे, वापस से लिक्विड फेज में यानी कंडेंस होने शुरू हो जाएंगे, और कुछ के जो है वो पार्टिकल्स वो बार बार हवा में उड़ते रहेंगे। तो ये प्रोसेस ना कंटिन्यू रहेगा, ये प्रोसेस कंटिन्यू रहेगा। समझ आया? यू
Yes,
अंडरस्टूड
sir.
कि कब मतलब दिस इज कॉल्ड,
Yes,
वी
sir.
विल सिंपली से दैट दिस इज नोन एज इक्विलिब्रियम। द इक्विलिब्रियम इज द रेट ऑफ condensation means the vapor particles coming into the liquid state is equal to the rate of the particle that are evaporating here. Okay, so
Okay, sir.
this process will remains continue. Then at this state they will exert some pressure on the wall of the container at equilibrium if it is a closed container. So we will note this pressure here, what pressure they are exerting right now, and this is known as the pressure, the partial pressure of the pure solvent or pure substance. Okay,
Yes, sir.
understood? So at this time there is no B particle, only A particle is here.
ऊपर वेपोर
Sir.
एक प्रेशर क्रिएट करता है, इसे हम वेपो प्रेशर कहते हैं और इसे हम प्रेशर गेज से मेजर कर सकते हैं, जैसा कि एनिमेशन में दिखाया गया है। जब हम सॉलिड सॉल्यूट पार्टिकल्स को सॉल्वेंट में ऐड करते हैं तब सॉल्यूशन इवैपोरेट होना शुरू करता है और इस बार भी वेपो फेज में सिर्फ सॉल्वेंट्स के पार्टिकल्स हैं, जो कि वाटर है। ऐसा इसलिए क्योंकि सॉल्यूट वॉलेटाइल नहीं होता।
यहाँ पर जो सॉल्यूट है वो वॉलेटाइल, बिकॉज व्हाई द सॉल्यूट इज नॉट वॉलेटाइल, because solid, the particles of solid do not evaporate. Okay, you know that if you are just evaporating, if you are having a mixture of salt and water, okay, so will the particles of salt evaporate?
No, sir.
No, because you know that during that time they will not evaporate. Why? Because it is solid particles. Solid particles will remain in the bottom. Okay, it will not evaporate. So same thing happens here is that when we are just evaporating the solid particles, then during that times only the particle of the solvent will decrease. But you will notice one thing here, that the surface of evaporation will decrease, and you know that evaporation is directly proportional to the surface area. Evaporation is directly proportional to surface area. More the surface area, more will be the rate of evaporation. You know this one. So if on the surface there are some particles, if first just imagine that a surface which is having only green particles, so the particles for the evaporation for the green particle will be, the surface area for the evaporation of green particle will be more. Are you getting
Yes,
this?
sir.
But if you are having some particles like green and then yellow, then green, then yellow, then on the same surface the surface area for the green particle will decrease. Why? Because there is yellow particles is also coming here. Yellow particle is also coming here. You understood?
Yes, sir.
Okay. So let you on.
अब हम पाते हैं कि सॉल्वेंट में सल्यूट ऐड करने के बाद सॉल्यूशन का वेपो प्रेशर प्योर सॉल्वेंट से कम है। ऐसा इसलिए क्योंकि नॉन वॉलेटाइल सल्यूट पार्टिकल्स सॉल्यूशन के कुछ सरफेस एरिया को घेर लेते हैं, जैसा कि एनिमेशन में दिखाया गया है। हम पाते हैं कि पहले के कंपैरिजन में अब वेपो कम क्वांटिटी में बन रहे हैं। रॉल्स ने इन सब बातों को ऑब्जर्व करते हुए ये पाया कि सॉल्यूशन के वेपो प्रेशर का नॉन वॉलेटाइल सल्यूट से क्वांटिटेटिव रिलेशन है, और साथ ही रॉल्स लॉ दिया। थैंक्स फॉर वॉचिंग। इफ यू लाइक दिस वीडियो,
You understood?
Yes, sir.
The pure solvent. Now, what was I was explaining you here, that when there are two volatile liquids. Now, if they are two volatile liquids, then the both will exert some pressure. Okay. This was having the one volatile solvent and the non-volatile solute. Okay. That will just going to study the two portion here. The two parts will going to study here. But if they are both the liquids are volatile, then they will exert the pressure. They will exert the pressure. Okay. They both will exert the pressure, and that pressure will be directly proportional to the pressure exerted by the each liquids. Each liquid will exert some pressure in the container, like P and PB both will exert the pressure. So we'll simply say that PA partial pressure directly depend on the mole fraction, that how much amount of this substance is present in this liquid. If the mole fraction is of A is there in the liquid, then the pressure exerted by A will be more as comparison to the B. Now you understood?
Yes, sir.
Understood? Now here PA is equals to PA naught into XA, then PB will be equals to P naught into A into XA. And this is the pure state. Okay, now you see that P total will be equals to PA plus PB. And here we add this two, and now we put this value here in place of A, and in place of B we put here. We just replace this 1 and 2 because you have written this one in the copy from this printed portion. So you write here PA naught is equals to, again, then we just replace this XA with 1 minus X2. 1 minus X2 because X1 is equals to 1 minus X2. Okay, mole fraction. You know the sum of X1 plus X2 will be equals to 1. So this will be equals to 1 minus X2. So we just put here. We just multiply these two. We will get P1 minus P naught X2. And then we take the X2 common from both. And this we write P2 here and P1 here. And this is the P total. Okay. Now you understood?
Yes, sir.
If you are not getting this one, then we're going to explain you one more time. Okay. But let's means when we read the other portion or we study the other portion of this topic, so you will be able to learn this one. Okay. So let's move further. Just stop. Okay. Now there are the two cases. Okay. There are the two cases. That was explained in the video. There are the two cases. Okay. The one case is case one. Case one is that when we have non-volatile solute, we have non-volatile solute. Okay. Like we are just having B and added with volatile solvent. Volatile solvent. Okay. That is A. Solvent, we know that it is A, and in B, we know that the B is solute. With that, we were also practicing in the previous one. Now, according to this one that we have also discussed, okay, that we have also discussed that in this one, in the previous one, and as we were watching in the video, that if you are adding a solute in a volatile solvent, so in the pure state, it will exert more pressure. In the pure state, it will exert more pressure. Why? Because there are only A particles. But you know that the particle of the solute do not evaporate. The particle of the solute. So if we add solute to it, then some of the particle will come and over the surface, and we'll simply say that now it will not evaporate. Only the surface particle that can evaporate is this particle can evaporate, this particle can evaporate, this particle will evaporate, this particle, and this one, this one. And previously there was only the fresh surface of the black one only. Okay, only the solvent. But if you are adding some solute to it, then the particle of solute will also come, and thereby it decreases the surface area for the solvent to evaporate. Okay, so for example, if I add some sugar in the water, okay, so the temperature, or we can say that the vapor pressure of the water will decrease, or we can say that the water will boil at higher temperature. Okay,
Yes,
you
sir.
understood? Are you getting this one?
Yes, sir.
Okay, so note it down. When non-volatile solute is added to pure solvent, note it down. When non-volatile volatile solute is added to pure solvent, then some part, then some part of surface area is blocked, okay,
Yes.
by solute particle, due to which rate of evaporation and rate of condensation are decreased, so the equilibrium is obtained comparatively. So the equilibrium is obtained
Yes, sir.
comparatively at lower vapor pressure. Lower vapor pressure. Vapor pressure. This decrease in vapor pressure is called lowering vapor pressure. Lowering vapor
Yes, sir.
pressure, which is measured with respect to pure solvent. It is measured. If it is measured with respect to pure solvent, then it is known as relative lowering vapor pressure. Relative lowering of vapor pressure.
Yes, sir.
You done this one? When you done, please let me know.
Okay, sir.
Done?
Last line, sir. Yes, sir.
Okay. Now, what you understood here is that, for example, the pure solvent has the highest vapor pressure. Okay. The pure solvent has the highest vapor pressure because only the particle of pure solvent is present and they can easily evaporate. Okay. And now if you are adding some salt to it, then the vapor pressure will decrease.
Yes, sir.
Okay. The vapor pressure will decrease. Why? Why it will decrease? Because the surface area will decrease. Because the B particle is also coming here. The surface area for this one that I'm just drawing, that for example, this is the color for the this particle is solute particles. That dark particles is solute, dark blue, and the sky blue is for the solvent, or you can consider anyone. So if this particle was having purely, previously they were evaporating, so they will exert more pressure because there is more number of particles will evaporate easily. But if you are added some solvent to it, solute to it, and it is not evaporating, it is non-volatile substance, then in that case, non-volatile means it will not evaporate, not evaporate means it will not exert any pressure. So in that case, we will say that the vapor pressure will decreases. So if you consider that, let you consider that the initial pressure is X. Okay. Initial in the pure state. This P naught means in the pure state. Okay. Or you can consider that if the initial partial pressure is 2 atm, 3 atm, whatever it is. And after you add some non-volatile substance, then the partial pressure of this pure substance, that it is solvent and it is also solvent, then it will decrease. So what is the amount of decrease is known as, means the previous one. For example, if it is having 3, now it is having 2.5, then the difference between this, the previous one and the original one, now the recent one, is known as relative lowering of vapor pressure. Okay. You understood?
Yes, sir.
What is relative lowering of vapor pressure? Tell me.
Uh, it's when the vapor pressure is like decreased.
For example, if you have pure ethanol, okay, pure ethanol
Yeah.
dissolve or pure ethanol evaporate and exert a pressure, for example, 3 atmosphere, 3 atmosphere, 1 atmosphere, 1.2 atmosphere, it can exert. Okay, you understood? It is exerting the pressure here. Now this is the pure ethanol particles here, only pure ethanol. Now if you add some solute to it, non-volatile solute to it, now it is not having pure ethanol particles here, it is also having the solute particles.
Yes,
Okay.
sir.
Now the pressure will decrease. Why? Because the surface area will increase. Surface area of this solvent is decreased. So we will simply say here that, what we will say, that the less number of particle will evaporate. So less number of particle will evaporate, so they will exert less pressure. So let now it is exerting 1.5 or 1.2 or 1.6 or whatever it is. Okay, let it is decreased. So let it is decreased by 2.5 atmosphere. Got it?
Yes, sir.
Now the relative lowering of vapor pressure is the difference of these two, from the original to the now when it is added to the. So when you add some non-volatile solute to it, then the original pressure of the pure solvent decreases just because of addition of some non-volatile solute. Okay, and this is known as relative lowering of vapor pressure. You understood?
Yes, sir.
Okay, I can just now just concentrate. Just wait a minute. Let's have some question over it. Here is a question. What is saying here? That the vapor pressure of chloroform and dichloromethane at 290 Kelvin is 200 mmHg and this mmHg respectively. Okay, so this is what is it given here? What is it given? It is given in its purest form. Vapor pressure of this one is 200 and this one is 415 mmHg. This is also mmHg. Okay, respectively. Calculate the vapor pressure of the solution prepared by mixing. And when you are mixing, there's 2.5 grams of CH3, this is chloroform, with 40 grams of this one. Okay, so calculate the mole fraction when you mix this amount. So what is the mole fraction of each? And second, the mole fraction of each of the component in the vapor phase. So first, what you will do? What you will do? First, you will calculate the mole fraction, because when you are mixing this one, then this will become P A, or you can say PCH3 will be equals to P naught into XA. P naught into XA. P naught is given to you. Calculate the value of XA. XA means CH3Cl. So how can you calculate this one? First, calculate the number of moles of this one in 25.5 gram and that of 40 gram of CH2Cl2. Calculate its number of moles. So how will you calculate the mole fraction? You know that XA, first you calculate the number of moles. So what is the number of moles? Number of moles Na, that will be 20 to 25.5 upon. What you will get here? CH3. CHCl3. What you will get here? What mass you are going to get? The molecular mass. Calculate its molecular mass, please.
Yes, sir.
That is 12 plus 1 plus 75. Sorry, not 75. That is 35.5 into 3.
Yes, sir.
You get here 13 plus 106.5. 106.5. Okay. Then you add
Yes, sir.
these two, what you will get?
80 plus.
You get 119.5.
Yes, sir.
So divide with 119.5. Okay. What value you are going to get here? You will get how much moles? You divide it, you divide it by 5, you will get 5 5s are 5 1s are. You divide it 5 2s are 10, then 119, 5 3s are 15, then 4 5 9s are 45. Okay. 239.
Oh.
Then you know 51. You divide it further. If it is divisible by 3. No, it is not divisible by 3. Okay, then check it whether it is divisible by 17. 17 ones are 17, 17, and then it is 3 and 3 6 39. Okay, let you divide it by this one. 51 divided by 239. Okay, you put the decimal here because you cannot read the table even once. Okay, and then you multiply it by 2. Divide by 2. Okay. So when you divide,
Okay.
then you get 239 into 2. What you will get?
239
You will get 478.
Yes, sir, I get.
478. Then you will get 2 here. And then you will get 0. 0 minus 7. You will get 7. 3. 3. 32. Okay. 32. And since the decimal is already present here, so you place decimal here and you will get 310. You will read the table once. You'll get 239. Okay.
Okay, sir.
What you will get here? If it is 40, 240, and this is 20, so you will get 60. Okay. Okay, you can write 1, and this is 12, and this is 81. Okay. Now it is already
Yeah.
present here, decimal, so you can write here what? You can read approximately 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8. Approximate 4 times. Okay. Or approximate 3 times. So you will get approximately the answer as 213. Okay. As a mole fraction of XA. Sorry, number of moles of A, not the mole fraction, number of moles of A. Okay, and A.
Yes, sir.
Now what is the number of moles of B? Calculate the number of moles of B. Same. It is 40 gram. Given mass is 40 upon how much?
On 298.
Yes. CH2Cl2. That is 71 plus 14. 12 plus 2, 14. How much you will get? 5 and 8. 85. You divide
Yes,
it
sir.
by 5, you will get 8 5s are 40 and 17s are okay. Then how much moles you are going to get here? 8. 18 to 17 you divided by how much you will get?
18 into
Point
17.
you will place decimal here.
1 point. Yes, sir.
Approximately 4. You will get 68 here. Okay.
Okay, sir.
And then you will get 2 and then you will get 1 here. Okay. And then 0 since the decimal is already present. 0.47 moles. You understood?
Yes, sir.
Now the mole fraction you can calculate. How will you calculate? This is the number of moles of A and number of moles of B you have calculated. So how did you calculate the mole fraction? So XA is equals to number of moles of A. Number of moles of A. What is A? Number of moles of A is 0.21. Okay, 213. And here that is 0.213 plus number of moles of B. That is 0.47. Got it?
Yes, sir.
Or you can consider it as 0. Now calculate the mole fractions of XA. Just consider this is 0.21. Now you will add these two. So X will be 0.21 upon, you add these two, what you will get? 0.21 plus 0.47. What you will get? 8 and then 68, 0.68.
Yes, sir.
And you can remove the decimals here right now.
Yes, sir. Um,
Then divide 21 by 68.
21.
You will place the decimal first
Yes,
and
sir.
we'll add a 0 here. Okay, 0 here. Now you know that 68 is nearer to 70. Okay. If it is exactly 70, then you will get approximately 7 into 3 will get 21. Okay, so yeah, this means approximately 3 times you can read the table. 68 into 3, how much you will get? 3 8s are 24. 2 carry, then 3 8s are 3 6 are 18,
204.
18 into 2, 204. Okay, so you will get 204 and remaining is 6. Then you put the decimal, you can't read the table once more. And then you read the 0 here, and then you add 1. So it is approximately 0.330. Okay, so A is equals to 0.30. So mole fraction of A, you know now.
Yes, sir.
Now, what's the formula for the P total pressure? What is the mole fraction of B? That will be 1 minus 0.30. That will be 0.70.
Yes, sir.
Are you getting this one, or it is going above the head?
It's a bit confusing.
Bit confusing. Just let me solve this one for you, then I'm going to help you, okay?
Okay, sir.
Next. Now, what is it asking here? Now, read the question one more time, please. Read the question one more time.
Yes, sir.
The vapor pressure of chloroform and dichloromethanes at 298 Kelvin is 200 mmHg on this one. Okay, just a minute, just a minute. It's coming back in.
So,
Okay, you read the question. You read the
vapor
question.
pressure. Yes, sir.
So
I
it
did,
is
sir.
the partial pressure. So what was your P total? P total is equals to P naught into XA plus P naught B into XB. P naught is given to you. The first one, what was the P naught is given to you? That is 200 mmHg. You will write 200 mmHg. 200 into what is the mole fraction of XA you get? 0.30 plus what is the partial pressure of B is given to you at the pure state. The pure state, it is 415 mmHg.
Yes, sir.
Only a single question. I'm going to explain you this one because this is an 11th standard and this is not an easy task. Okay, so just sorry, 12th standard. It's not an easy task. So don't worry about it. I'm just going to explain you one more time. This is 0.70. First, you calculate this. You will get your total pressure exerted. First, you
Okay, sir.
calculate it. What value you will get here?
Um, three, it's it's 60.
Yeah, you will get 60 here. Plus, what you will get here?
It's 1, 2, 1. It's 290.5.
Yeah, 290.5. Okay. That is 290.5. What's the total pressure? Approx.
3, 350.
350.5.
Yes, sir.
So this is the partial pressure that you will get. P total. Okay. This is 350 approximate. And when you do the exact calculation with the help of calculator, then the value might change. But the answer, when you do the exact and with decimals up to 3 digits. Okay. So when you do the decimals after the 3 digits, so then you can get this value. This is the approximate value. And you will find 347.9 means approximately 348. Okay. So since we have assumed the 2 decimals place, so the accurate calculations, okay, and then it's okay. The teacher will give you the marks, okay. Approx. When you write it approx, then he will give you the marks, okay.
Yes, sir.
Approx calculation up to 2 digits. Here it is calculating for the 3 digits decimal place. It is not taking the 0.70. We just assume that it is 0.70. It is 0.688. Okay. Got it?
Yes, sir.
And So just let me explain you one more time this question. Just let me explain you one more time this question. What the question says. Read the question. There are the two volatile liquids. One is the chloroform and other one is dichloromethane. Okay. One is chloroform, another one is dichloromethane. Okay. And they are having, when they are in the pure state, then they exert particular some pressure. They exert some pressure.
Yes, sir.
Okay. Just concentrate here because it is very important. And we assume that the chloroform exert a pressure of 200 mmHg. And okay, and here this dichloromethane exert a pressure of 415 mmHg respectively in the pure state. Okay. Now it is asking
Yes.
that when a solution of this, by mixing this grams of chloroform and this much amount of dichloromethane, if they both are mixed, any 40 gram this one and 25.5 grams chloroform, when they both are mixed, then they will exert some pressure. The pressure will be different. What pressure they are going to exert? So according to Rolle's law, we studied that the partial pressure of a gas is directly proportional to the mole fraction. And we have learned here that P1, PA, the partial pressure in the vapor phase, or in the when there is a solution, then PA is equals to directly proportional to the mole fraction, and that would be equals to PA will be equals to this value. What is PA naught? PA naught is the pure state and X is the mole fraction. Okay. Mole
Yes,
fraction.
sir.
Now what you did, similarly, PB is the second substance, that will be PB naught. Okay, that will be PB naught into XP. Okay, that will be PB. And when we add both, we will find that this value plus this value, it will gives you total pressure. So what we did the same thing that we done in the previous one here. So what we did, we just calculate the mole fraction. And you know what is mole fraction? So you have not practiced the question on the mole fraction. That's why you are just getting stuck here. So let me explain you. The mole fraction is represented by XA, for example, for XA is equals to number of moles of A divided by number of moles of A plus number of moles of B. And how you get the number of moles of A is equals to given mass. Now you understood? The given mass
So
of
actually,
A divided by molar mass of A. So what is the given mass of A? What is the given mass? That is 25.5. And what is the molar mass of A? CH3Cl. That is 119.5. So what we did here is we divide this value. To find the number of moles of A, we just simply divide it.
yes, sir.
And we divide, then we get the number of moles of A as 0.213. 0.213, which is we just consider it as 0.2. Okay, in the 2 digits.
Okay, sir.
Okay, is that clear? Is the number of moles
Yes.
of it? We have just find out. Now what we did here in this question, then again we find the number of moles of B, the number of moles of B. And how we will find the number of moles of B? The given mass, that is 40, upon its molar mass, that is 40, and the molar mass of CH2Cl is CH2Cl2 is, what is the molar mass? That is 85. The 40 divided by 85, you will get 0.47. You understood?
Yes, sir.
Understood?
Yes.
Understood?
Yes, sir.
Now, what you did here is that now you find the number of moles of A, number of moles of B. Now you can calculate the mole fraction of A easily. So what you did here, you find the mole fraction of A. What is the mole fraction of A? Simple. You write the value here. That is 0.21 upon 21 upon 0.47. The mole fraction, if you need to calculate the mole fraction of A, you write the number of moles of A upon number of moles of A plus number of moles of B that you have already calculated here. That number of moles of A is 2.01. Then again, number of moles of A is 2.01 and number of moles of B is 0.47. You just put that value here. And you find this value. When you add this two, you find that 0.68. When you divide it, you find this value approximately 0.7. Approximately. Okay. Is that clear?
Yes, sir.
Now, if you know that if the approximate value of this one is A is 0.30, then the mole fraction of B, XB, will be 1 minus 30, because you know that if we know the mole fraction of A, just subtract this value from 1, you will get the mole fraction of B. So you just get this value. Now you put the formula that P total will be equals to PXA, P naught into XA plus P naught B into XB. So what is P naught? P naught is the initial state pressure that is given to you, that is 200. That is 200 here, 200. So 200 into mole fraction of A, that is 0.3 that you have calculated here, mole fraction of A. Then 415 is the pressure, pure state vapor pressure that you write here, and then you write 0.47. And then you calculate this value, you will get 350 mmHg. So when you do this question one more time, then you will be able to do this one. Okay. So this is the question of the day. Just you need to concentrate here. Just you try it once more time, please. So I'm just going to write this question again for you, and then I'm just helping you again because this is the question. If you did this question, then the Rod's law questions you will be able to perform. Otherwise, everything will be stuck. Okay, you will not be able to perform. Performance is
Yes, sir.
important. Even if you learn something for a single day, that's enough. Okay, I'm going to write it for you. So what is given to you? So first of all, it is given. Write down the biography in the proper way. That P naught A is given to you. That is what? That is 200. P naught B is given to you. That is 415 mmHg. You understood?
Yes, sir.
Now, what is saying here? Calculate the vapor pressure. So the formula here, vapor pressure means total vapor pressure. When they both are mixed, they are prepared by mixing. So both are mixing. So we will write the formula P total is equals to P naught A into XA, mole fraction of A, plus P naught B into XB, the mole fraction of B. This is the formula that is going to be used. So what you need to calculate is, you need to calculate first XA. How will you calculate the mole fraction of A? So for mole fraction of A, first you need to calculate the number of moles. So what is XA actually? XA is equals to number of moles of A divided by number of moles of A plus number of moles of B. You understood?
Yes, sir.
That would be equals to, what is the given mass of A? That is 2.5. So you will add 25.5 divided by this value, that is this. When you calculate this mass, you will get 119.5, the molecular mass of A. Okay, CH3Cl is,
Yes.
the molecular mass of CH3Cl is 119.5. Okay.
Yes, sir.
And when you divide this one with 20, again, mole fraction of 25.5 on 119.5 plus, what is this value? Mole number of moles of B. So how will you calculate the number of moles of B? Given mass of B, that is 40 upon molecular mass of B. What is the molecular mass of B? You find this is 85. Okay.
Yes.
So when you solve this value, you will get it as 2.1 approx. When you solve this value, you will again get 2.1 approx. 2.1 approx. It's the same. Numerator and denominator. See? And then again, when you solve this value, what you will get? You will get approximately 0.47. 0.47. Okay.
Yes, sir.
So when you divide it, you will get 0.47. So when you get this value, when you add this two, you will get 2.1 divided by 6.8. You remove this decimal, you cut it, you will find that it is approximately equals to 0. Exact value is 0.688. That is equals to 0.7. You can consider it as 0.7.
Yes, sir.
Okay. because we are doing the approximation. So this is 0.7. Okay. And this is the mole fraction of A. Got it?
Yes, sir.
Sorry, 0.3. So sorry, it will be 0.3. Yeah, it will be 0.3. Here it will be 0.3. It will be 0.3. 0.3 approx. Okay. 0.30. So this the mole fraction of A. What you get the mole fraction of A? When you solve all this, you will get XA is equals to 0.30. Got it? So what
Yes,
is the
sir.
mole fraction of B? That would be 1 minus 0.30. That is equals to 0.7. Is that clear to you up to here?
Yes, sir.
Now it is asking for the P total. So P total would be equals to P naught. P naught. P naught is given to you. That is P naught A is 200. Right here 200 into 0.30 plus 415 into XB. Mole fraction of B is 0.70. So you will get 60 here and you will get here 290, 290.5. Na?
Yes, sir.
Okay, when you add these two, you will get 350.5, 50 approx. So this is the partial pressure. Now you understood?
Yes, sir.
Now this is the approximate, this is the P total. P total. Now you have to concentrate here. What we are writing here, the mole fraction of the liquids. Liquids. Okay, this is the mole fraction of the liquid that is in the solution. And this is the mole fraction. This is the mole fraction of A. This is the mole fraction of B. But do you think that the same amount that will be present in the vapor phase also? No. All the liquid is not going to evaporate. The same amount of vapor pressure will not be present. So what it is asking in the question here is that find the mole fractions of each component in the vapor phase. The mole fraction in the liquid phase is different that we have calculated here. This is the in the liquids, and two liquids are mixed together. We just the amount of liquid upon the molar mass of the substance, that liquid A, and then again we put this value, we get this value. But do you think that in the vapor phase, all the liquids, the amount will be same? This amount will be same? No. So what we are going to do here is that what we are going to do here for the mole fraction in the vapor phase. So mole fraction in the vapor phase will be equals to P total, sorry, P naught divided by P total. Mole fraction in the, sorry, P, that would be, you know that P total. So P total is equals to, we know that is P total that you get here is equals to P naught in the vapor phase into mole fraction of A. This is P naught in the vapor phase. Vapor phase. So just you divide the P total, that you get 350. Okay. And then you will get the value. No, just a minute. And P naught in the vapor phase. You know that it will be P total divided by P naught. What is P total? That will be 350.50 upon P naught. P naught in the initial state, in the pure phase. What is that in the pure phase? That is 200 mmHg. So divide it and you will get this value.
Yes, sir.
So this is the way that you will be able to solve this type of questions.
Yes, sir.
Let's have one more last question over this. then we're going to leave. So, what more questions over here? So here we have the next question. Try to solve it. What is being given to you? First read the question 2 or 3 times, then you will be able to solve this one. The partial pressure of ethane over a solution containing 6.56 grams of ethane. 1 bar. It contain, if the solution contain this grams of ethane, what will be the partial pressure of the gas?
Yes, sir.
Which law you are going to use here?
Henry's law.
First calculate the value of KH for the ethane. So P is equals to KHX. Okay. Now it is saying that the partial pressure of ethane over a solution containing this grams of ethane. So what is this?
Oh,
This is 1 bar. 1 bar it is given to you, and KH you have to calculate. Okay.
yes,
And
sir.
then X of ethane. So what is the mole fraction of ethane? Mole fraction of ethane. So how will you calculate? Because you know that mole fraction of ethane will be very, very less in our solution. So for a very dilute solution, and when in case of especially gases, we can consider the mole fraction of ethane as number of moles of ethane divided by number of moles of B. Okay, the water. Got it?
Yes, sir.
Now just concentrate here because we don't know the B. The number of moles of B we don't know. Because it is not given, the amount of the ethane is not given to us. Okay. Now the same solution, what is it is asking, we just compare it. So you know that KH is constant for both. So for this case, we can consider this as mole fraction of ethane for the first case. Okay. Now this is P, 1 bar. It is given to you. Now KH is constant. So you can write that KH for the first case will be equals to pressure first, P1 upon mole fraction of ethane. Okay. In the first case, this will comes down, or you can write it properly. This will comes down. This concentrated, this is a very easy question. Mole fraction of ethane. Okay, you got this? Now the second case, the KH for the particular gas, the KH value is fixed. Okay, it does not change. Now here you will find that the pressure, if the solution contains this grams of ethane, what will be the partial pressure of the gas? So it is saying that the partial pressure P2 it is being asking for the second case, and that is the mole fraction of ethane. Second, for the second case, just concentrate here. Are you getting this?
Yes, sir.
You write mole fraction of ethane for the second case. Okay, and that is KH here. The both will gives you the same KH value. The KH is same for both. So we'll write here, equating this first equation and the second equation. What you will get here? You will get here P1 upon the mole fraction in the first case in the ethane. Mole fraction of ethane in the first case. So just writing here 1 will be equals to mole fraction P2 upon mole fraction of ethane in the second case. Okay, got it?
Yes, sir.
Now just concentrate here. This is important. Now P1 upon what is the mole fraction of A? You will get number of moles of A. Okay, number of moles
Yes.
of A of ethane in the first case upon number of moles of A plus number of moles of B. Okay, that will be equals to P2 upon number of moles of A, but this is the first case. Yani this is the ethane man is the first solution when ethane is only this much amount is present. Okay, and in the second case, it is the same ethane gas, but it is present in this amount. So I'm just writing this one X number of moles of A, but this and this are not equals because they are different in amount. Okay, so this is writing A1, A2, A1 number of moles of 1 in the second case, number of moles of ethane in the second case upon number of moles of B. Okay, up to here, did you understood or should I explain you one more time?
Understood, sir.
Understood? What is saying
Yes,
that?
sir.
Let me explain you that. Read the question. Here it is saying that the partial pressure of ethane over solution, that is 6.5 grams of ethane, is given to you. So you will calculate the P is equals to KHX. Now you don't know the value of KH. So it's okay. We have the two cases. We just write the KH and we just bring this mole fraction of ethane here in case 1. Case 1. Okay. Here is the second case in which the amount of ethane is this one, but the KH value is same because it is an ethane gas. So the P2, the pressure it is asking that the next partial pressure will be considered as P2 because here the mole fraction of ethane in the second case will be changed. Okay, but the value of KH is same. So since that this is also, this value is also equals to KH and this value is also equals to KH, so both we are just equating. So we just equate this both. Okay, P1 upon P2 methane. This is ethane, mole fraction of ethane in the case 1, and it is the mole fraction of ethane in the case 2. Mole fraction of ethane in the case 2.
Yes, sir.
In the case 2. Okay, case 2. Now, Thameem, you need to concentrate here. Since B is not given to us, neither the weight of B is given to us, number of moles of B, nor it is given that it is water or something else, we don't know. Okay, so you know that when the gases are dissolved in the liquids, then the mole fraction of gas is very, very less as comparison to the mole fraction of solvent. So for gases, we can write that mole fraction of ethane will be equals to number of moles of ethane, number of moles of ethane upon number of moles of ethane plus number of moles of solvent, But since this value is very less, so it will be rejected. Simply we can say that for gases, mole fraction definition is mole fraction of B will be equals to B indicate the solvent or ethane that will be equals to n number of moles of B plus number of moles of A. We just neglect here B. This value is neglected. We don't write it. So similarly, this formula can be further written like P1 upon number of moles of ethane in the first case divided by number of moles of B. Okay, and B is same because that is the same amount of, okay. Similarly, P2 will be equals to number of moles of uh, ethane in the second case upon number of moles of B. Now, this B and B will cancel out each other because these are equation. This will cancel out each other. So you can write here that P1 upon number of moles of ethane in the first case will be equals to P2 upon number of moles of ethane in the second case. So P1 partial pressure is given to you 1 bar. Number of moles of ethane is ethane. Ethane is CH4. Sorry, C2S6. Ethane is C2S6. So what is the formula? What is the molecular mass of C2S6 calculated?
It's 30.
What is?
30.
24 plus 6 is 30. So, okay. So you will write here 30. Sorry, given mass is, what is the given mass? Number of moles formula is given mass upon mole 1. That is 6.56 divided upon 10 to the power minus 3. You can write it 6.56 into 10 to the power minus 3 upon 30. This is the number of moles of A in the first case. Second, you need to calculate the P2, and it is how much amount of this time is given in the second case? That is 5.0 into 10 to the power minus 2. So you will write here 5.0 into 10 raised to the power minus 2 upon 30 again. This 30 and this 30 will again cancel out each other because that is in the denominator. So this will cancel out if it is equated. Okay. So this will cancel out each other. Now you can easily calculate 1 upon 6.56 into 10 to the power minus 30 will goes. This 3 will goes upside. It will become positive 3 is equals to P2 upon 5.5 into 10 raised to the power minus 2 will goes upside and it will become 10 to the power positive 2 into 10 to the power positive 2. Okay. And this 10 to the power minus positive 2 will cancel out with this and you will get only 110 here. Because there is, you can consider this one is 1000 upon 5.6. This one is P2 into 100 upon 5. You cancel this, you will get only 10 here. You understood? This is the simple mathematics.
Yes, sir.
Now this 10 will goes to this side. You will get P2 is equals to 50, or you can write 5 into 10. 5 into 10 divided by 5.56. Okay. Now you can assume this one is 55. Means 6.55. So 5 upon 6.55, you can assume this one like this way. You cancel it. You will get 5 ones, then decimal, then 1 carry 15, 15. Okay, and then 5 ones are 5. So you will get 1.31. So you will get P is equals to 10 upon 1.31. Okay, and then you divided 10. You will get this value. You will get 1000 to 0 here. So you will get 1000 divided by 131. So approximately how much? Approximately 8 times. 8 is 24. 7 times. So 13 7 is 91. So 7. So you multiply by 7, 7 1 is 7, 7 3 is 21. 2 carry 7 1 is 7 and 2 9. 917. You will get 13. You cut it, you will get 7. Okay. So you divide it. So you will get how much? 87, 83 here. Okay. Then you put the decimal, you get here. And then you put further 13 1 is 13. 13 5 is approximate 4 times. So you will get approximately 7.4 bar as a pressure. Let you concentrate one more time. I'm going to explain you this question. Thameem, this is the first question. Just you concentrate. I'm just going to leave you. Okay.
Okay, sir.
Is there iftar timing there or not?
Oh, iftar finished, sir.
Iftar finish in the class.
No, like right before class started.
Okay. So you just concentrate. The partial pressure of ethane over a solution contain this value. Okay. This is the weight. This is in grams. Okay. Given mass of ethane is 1 bar. It is given to you pressure. If the solution contain this value, this much of ethane, means more amount of ethane is added, then what will be the pressure, partial pressure of the gas? So according to the Henry's law, we studied that partial pressure of a gas is directly proportional to the mole fraction. Is that clear? We just learned this one in the previous class. Okay. Okay.
Yes,
Okay.
sir.
Then what you will write here? P1 is equals to mole fraction of ethane. This will comes down. You will get the value of KH. This is the for the case 1. If case first, when this much amount of ethane is there. Okay, that for the case second, again you will get the P2 will be the second partial pressure, and then this methane will come, the mole fractions of ethane in the second case is the KH. Since this value, the first value and the second values both are equal to the KH, so we just equate this one. We just equate this one. Like, because we don't know the value of KH, how can we find out? So we just equate, we just eliminate the value, we just equate this one. P1 upon mole fraction of ethane in the case 1, and P2 upon mole fraction of ethane in the case 2. Now we write the P1 upon mole fraction of, what is mole fraction? Mole fraction of ethane or anything is equals to number of moles of A in the first case of ethane, then here and then this one. Number of moles of A plus number of moles of B in the first case. And second case in the second case, it will be number of moles of ethane solute upon number of moles of solute plus number of moles of solvent. And since you know that the here in the gases case, the mole fraction of solute is very less. So we will just reject this one. We will reject the number of moles of solute. Okay. So we'll reject this value, we'll reject this value. We'll find that number of moles of ethane. This is A means ethane. We are just considering here ethane. Divided by number of moles of B. Here same number of moles of ethane divided by. With this will cancel out each other. B will cancel out each other. We just write here P1 upon N1 and same P2 upon N2. Now we just number of moles of ethane. The first case will be this value divided by molar mass. And since this value divided by molar mass, we just cancel out the molar mass. And you will find this 1 upon this value will be equal to this 5 will comes down, this 10 will be, you solve it by simple mathematical rules and you will find this value that you will get pressure as 7.4 bar. Because the more gas is added, the more pressure will be exerted. Okay. So have you noted down
Yes.
this question?
Noting it down, sir.
Please note it down and try to understood the question, that what it is saying and why I'm just following this step.
Yes, sir. Done, sir.
And also,
Yes, I will write this.
I'm not going to give you any homework today, and you have to practice this question that I have given you. Okay.
Okay, sir.
that we have discussed in the class, because this is, and try to solve the NCERT questions, the topic that we have studied. Otherwise, it will means you will not be able to understood properly and not able to get what students generally stuck, because they don't open the book. They totally dependent on the teacher. They just think that we will be able to do that one by our on notice notes. You have to practice the question, otherwise you will not be able to get the 100% that what we are studying. Okay.
Yes, sir.